the sum of the first two n terms of 1, 1, 2, a half, 4, a quarter, 8, an eighth, 16, a 16th is. Okay, so the first thing that came to mind as I was reading this out, of course, we have to see the pattern here. All the odd terms are just powers of 2, 1, 2, 4, 8, 16. And the even terms are reciprocals of powers of 2, 1, a half, a quarter, an eighth, and so on. If I split this up into two different series, one corresponding to the odd terms and one the even terms, then they're both geometric series. They both have a first term of 1. And they have a common ratio. One of them has a common ratio of 2. The other has a common ratio of a half. And with geometric series, we have, we have a closed form expression for the value of it. And so this should just boil down to a little bit of algebra. Now, I'm not 100% sure that this is in fact the correct formula. I might have a problem with those indices there. So let me just check for a couple values of n, whether this works or not. When n is equal to 1, the way I've written it out, n represents the total number of terms. So when in one of the series, so of course the total number of terms in both series is 2n, like the question asks. So when n is equal to 1, the only term I'm left with is this one. When n is equal to 2, I have two terms, 1 plus 2. So let me substitute n is equal to 2 and make sure that this turns into 3. Okay, no, it seems I have an issue with the indices here. Let me substitute one more value of n to make sure. Yeah, so when n is equal to 3, I should get 7. So it looks like I just have, I don't need to subtract 1 like that. Okay, and now it's just a question of simplifying things. Okay, so this is what I get after some algebra, but let's see if that's one of the options. It is. This is the first option, A. So yeah, I'm pretty confident with this one. A little bit of stumbling around in terms of trying to find the right formula for this geometric series. But, I know generally what the formula looks like. It's just a question of what convention you're using for the index or for the number of terms, whether you're starting at 0 or starting at 1. But just by checking the first few terms to make sure that the formula works should be enough. Yeah, and the other key here, of course, was recognizing that if I take only the odd numbered terms in the original sequence, then those just give powers of 2, and the even numbered terms give reciprocals of powers of 2, and both of those are going to be geometric series. So pretty easy to figure out the formula. If I have more to say about this one, I'll put it in the description. Thanks for watching.